An ocean on the brink, life slipping away faster than we ever imagined. With these few words, a disbelieving scientist at a marine research station in the United Kingdom recently tried to capture the full scale of our planet's latest environmental crisis. At first glance, it might sound like a dramatic exaggeration, designed to grab headlines. Yet lurking beneath the waves is an unfolding catastrophe so immense, so transformative, that calling it dramatic barely scratches the surface. Welcome, everyone, to a story of hidden chemical shifts and global consequences. A story about the acidification of our oceans. What does it really mean when experts declare a planetary boundary has been crossed? And especially, how does this invisible threat impact all of us, far beyond the sites of coral reefs or shellfish farms? In this deeply revealing exploration, we will uncover the dire warnings of leading marine scientists, reveal how decades of increasing carbon dioxide emissions have triggered a cascade of chemical changes across the seas, and address whether anything can turn the tide before it is too late. The shimmering surface of Earth's oceans has always held a certain magic for explorers, naturalists, and travelers alike. But the real action is not on that placid surface. Beneath the rolling waves, in the top 200 meters, a silent transformation is taking place. Marine researchers refer to it as ocean acidification, a chemical shift powered by the relentless absorption of carbon dioxide. The more carbon dioxide we pump into the atmosphere, the more dissolves into the water, reacting to create carbonic acid. Over years, decades, and centuries, this subtle chemistry accumulates, lowering the pH of seawater, driving levels of certain carbonate ions down, and creating a harsh environment for many marine organisms. The crisis is not simply a vague threat for some distant century. Multiple regions have already crossed safe boundaries that top scientists originally thought would shield fragile ecosystems. Specifically, a new study led by Dr. Helen S. Findley from Plymouth Marine Laboratory, published in Global Change Biology in June 2025, found that, alarmingly, a revised protective limit was crossed as early as in the year 2000. And if that were not bad enough, by 2020, the original threshold, 20% decrease in a crucial measure known as aragonite saturation state, was also surpassed. It might be hard to visualize chemistry in action. So, let us consider the vital concept of the aragonite saturation state, often referred to by scientists simply as omega-arag. Aragonite is a form of calcium carbonate that corals, mollusks, plankton, and countless other creatures use to build shells or skeletons. With enough aragonite in the ocean, those organisms can grow robust and healthy structures. But as acidity rises, fewer inorganic carbonate ions remain freely available for these organisms to harness. This drop in omega-arag becomes a silent threat. Shells weaken, growth slows, and death rates creep upward. According to recent data, by 2020, around 60% of the upper 200 meters of the ocean, and over 40% of the sea's surface waters, had already slipped below the designated boundary for safe acidification. That means that from the crisp waters near the poles to the balmy shallows by the equator, living creatures that rely on carbonate shells and skeletons are struggling to maintain their protective armor. At some locations, corals and pteropods have begun to show signs of dissolution, and tropical reef habitats are dwindling. The numbers, like 43% loss of suitable habitat for tropical reefs, or 61% for the delicate pteropods of polar regions, can seem abstract. But behind them lie countless individual stories of organisms fighting a microscopic battle every single day just to survive. Coral reefs, often described as the rainforests of the sea, are biodiversity hotspots where vibrant fish, invertebrates, and marine mammals gather in complex, interdependent webs of life. Fraying those reefs has a ripple effect that undermines food webs, local economies, ecotourism, and environmental resilience. Likewise, pteropods, sometimes called sea butterflies, are small but critically important mollusks that feed many commercial fish species in higher latitudes. This means that even if you have never personally witnessed a pteropod fluttering through Antarctic waters, it is conceivably tied to the fish fillet on your dinner plate. As the ocean's acidity intensifies, so does the fragility of these key species, and eventually that frailty cascades upward to larger predators and, finally, to our own dinner tables. Up until recently, the notion that ocean acidification might remain manageable with moderate emissions cuts gave some policymakers a sense of optimism. But the discovered breach of a more protective 10% boundary, as early as in the year 2000, has shattered that complacent mindset. Our planet was already shifting. The clock started ticking decades ago, and these changes are accelerating. Each year of inaction pushes marine life further into uncharted territory, while the chemical composition of entire seawater regions continues evolving. For instance, the polar seas, long considered stable strongholds for certain forms of life, are now among the most vulnerable to acidification. Coupled with rising temperatures, these changes transform how creatures feed, spawn, and migrate. It is a slow-moving but relentless march, with dire consequences for biodiversity, fisheries, and tourism. Meanwhile, local stewards, fishers, and activists find themselves grappling with phenomena that might seem intangible in daily life, but will surely become visible when shellfish harvests decline, reefs erode, or entire fisheries collapse. All of those outcomes threaten not just livelihoods, but entire cultural traditions of coastal communities. Now, if you find these facts about the invisible chemical changes in our oceans both shocking and galvanizing, let us take a brief moment to strengthen our community. Please consider sharing this sense of urgency by hitting that thumbs up of support. Your engagement helps spread critical awareness in a world often saturated with fleeting news. After all, the more of us who stay informed, the greater our chances of spurring decisive actions that matter. From a purely economic standpoint, we also see an entirely new layer of concern. A prized sector of aquaculture, especially in coastal nations, revolves around bivalves like mussels and oysters. These organisms rely heavily on carbonate ions to construct their shells. According to the same groundbreaking study, roughly 13% of coastal bivalve habitats have already fallen below safe thresholds. For local communities who rely on shellfish collection or aquaculture, this is not just a statistic, it is profits lost and traditions jeopardized. In places like Greece, with thousands of kilometers of coastline and an economy that deeply intertwines with maritime activities, the stakes are enormous. The Eastern Mediterranean is known for its relatively warm waters and limited water exchange compared to the open ocean. When combined with overfishing, pollution, and the persistent warming of the seas, a burst in acidification compounds pre-existing problems, culminating in a multi-layer crisis. There is a stark difference between hearing scientists say the ocean is becoming more acidic and actually witnessing entire species vanish from local waters. Imagine an excursion off the coast of a Greek island, where years ago shimmering schools of fish thrived alongside vibrant sponges, sea stars, and succulent bivalves. As the decades pass, warmer temperatures and shifting currents reshape these communities. The thick layers of protective shells weaken, populations of foundation species dwindle, and the cascade effect leaves entire marine food webs teetering on the brink. That is not a hypothetical scenario for future generations. It may well be the near-future reality if carbon dioxide emissions remain high. The combined effect on tourism, coastal protection against erosion, and overall ecological health can prove catastrophic. A single shift in the acidity of a coastal zone might lead to algae blooms or degrade habitats where fish spawn, triggering a chain reaction that extends well beyond local niches. It is enough to fill an ocean lover's heart with dread, but it also should sound an alarm for everyone else. Even landlocked nations rely on stable oceans for weather patterns, rainfall, and an array of global climate services that are increasingly at risk. Historians often reflect on turning points, moments in time when crises accelerate or when societies realize that major actions must be taken. The data revealing that nearly 100% of the global ocean surface could surpass safe acidity levels by the year 2100 under mid to high emissions scenarios is precisely that type of wake-up call. Think about that for a moment. Imagine every inch of ocean water, from the tropics to the poles, pushing beyond chemistry levels that thousands of marine species have adapted to over millennia. The consequences would be monumental, from mass extinctions of coral reefs to the collapse of critical fisheries. In the face of such predictions, individuals, communities, and governments alike must decide whether to continue down this path or to engage in an unprecedented transformation of energy systems and carbon management. Science can highlight the problem and even propose solutions, but only collective commitment can make a difference. Many blame inertia among political and economic elites, pointing out that even after repeated global meetings like the United Nations Ocean Conference in Nice, the progress toward cutting carbon dioxide emissions remains woefully insufficient. Critics argue that small, incremental changes in energy policy or small expansions in marine protected areas fail to address the overarching trend of rising emissions that feed ocean acidification. Others highlight that bridging the knowledge gap is key. For too long, we have focused on what we can see: pollution, deforestation, melting glaciers, while ignoring chemical changes beneath the waves. That is what makes this new wave of research on acidification so important. The study in global change biology, authored by Dr. Helen S. Findley and her colleagues, signals a clarion call to everyone from local fishers to heads of state. The science is no longer uncertain, or a matter of maybe. The threshold has been crossed. Now we discover how to adapt and mitigate, or else bear witness to irreversible ecological upheaval. While there is still hope, the solutions will not be simple or quick. Transitioning away from fossil fuels to renewable energy sources like solar or wind is the backbone of reducing atmospheric carbon dioxide. Equally important is preserving and restoring natural carbon sinks, such as mangroves, wetlands, and seagrass meadows, which capture carbon dioxide right out of the air. Yet every year of delayed action makes these measures more painful to implement and less successful in protecting the ocean's chemistry. Ocean acidification stands as a prime example of how actions in one area of the planet, in this case greenhouse gas emissions in major industrial nations, can ripple out to all corners of the globe. This is not an isolated crisis. It is a global, system-wide challenge demanding unprecedented levels of collaboration. Breakthroughs in carbon capture technology, changes in agricultural practices, or development of robust aquaculture solutions that can withstand lower omega arag levels are possible. But they must be pursued vigorously, with no time to lose. If the daunting nature of this crisis has captured your imagination, please consider tapping that subscribe button to stay informed about future investigations into ocean health and climate solutions. Civic engagement often starts with a simple commitment to keep learning, and when you subscribe, you show your support for deeper, more nuanced environmental dialogues. In times like these, knowledge truly is power, and the more we equip ourselves with the insights gleaned from scientific studies and personal experiences, the more effectively we can push for broad societal changes that match the urgency of our realities. We should not forget the perspective of frontline communities, small island nations, and coastal regions that have historically relied on the bounty of the sea for sustenance and cultural identity. From the shellfish farmer confronting unusual die-offs of mussels to the fisherman discovering reduced catches of once plentiful species, these people are the first witnesses to ocean acidification at work. Many gather anecdotal evidence well before official scientific bodies confirm the emerging patterns. Already, in places along the northern Mediterranean, fishermen have reported species migrating to deeper or cooler waters. Warmer seas, combined with heightened acidification, create precarious conditions for certain valuable catches. Additional factors, such as plastic pollution or nutrient runoff from agriculture, only exacerbate the problem. While none of these factors alone might sink a fishery, their combined effects swirl into a perfect storm. Meanwhile, the lush Greek coastline that draws tourists to azure waters and ancient histories risks losing the vibrant marine life that enchants divers and snorkelers. One of the hidden marvels of Greek waters is the interplay of ancient rock formations and living reefs populated by sponges, anemones, and bright corals. This tapestry of life also forms the bedrock of local tourism. If reefs bleach and degrade due to acidification, if fish stocks migrate, if shellfish beds fail, imagine the ripple effect on hotels, restaurants, and guided tour operators. Although local stakeholders and coastal authorities have begun implementing measures, like establishing small marine protected zones or experimenting with artificial reefs, it is a race against the clock. Without global emissions reductions, such local interventions are like a bandage over a wound that continues to deepen. Still, they provide a necessary testing ground for innovative adaptation techniques that might buy us time or preserve certain habitats. One might ask, was the crossing of this planetary boundary inevitable? Scientists answer that while some changes in ocean chemistry are part of Earth's natural cycles, the speed and scale at which we have escalated carbon emissions for the last century and a half is entirely unprecedented. The sudden ramp-up in atmospheric carbon dioxide since the Industrial Revolution, and especially the dramatic uptick in the past few decades, has accelerated acidification in ways marine ecosystems have not experienced for millions of years. This tight time frame gives species little chance to adapt biologically. Whereas in the past, ocean pH and carbonate levels might shift over hundreds of thousands of years, today entire ecosystems must respond to changes happening in mere decades. The advantage humans possess is our ability to respond deliberately once we understand the threat. And now that we do understand it, ignoring the science or dismissing it as exaggerated is risking far more than a passing environmental headline. Human health is intrinsically connected to ocean systems, though that link is sometimes invisible to the untrained eye. Large parts of the world's population rely on fish as a primary source of protein. Coral reefs function as barriers for coastal protection during storms. Marine plants generate oxygen that we breathe, playing a role in the planet's carbon cycle. Reduce ocean productivity or undermine the health of coral reefs, and we risk losing lifelines that help sustain life on this planet. And while the ocean acidification story has rarely stirred the kind of public outcry that images of melting ice caps do, the cascading predicament caused by shifting seawater chemistry might in fact be more immediately dangerous. Given how many species' life cycles revolve around calcification, corals, bivalves, and certain plankton are like the building blocks of many aquatic communities. Degrade them, and you degrade everything built upon them. Over the coming decades, it may become a question of how robust and adaptable are the ocean's ecosystems. While some species might endure harsher chemical conditions, others will vanish. Where does hope lie? Paradoxically, one wellspring of hope emerges precisely from the depth of the crisis we now comprehend. We know, with scientific certainty, that drastically reducing carbon dioxide emissions can prevent more extreme acidification and possibly allow partial recoveries over centuries. If industries worldwide move to green energy sources, if reforestation and habitat restoration ramp up, then the worst-case scenarios might be avoided. On local and regional scales, protecting marine areas from pollution, overfishing, and other stressors can allow ecosystems some extra resilience, providing them the fortitude to endure an acidifying ocean a bit longer. The ocean, after all, has shown itself to be remarkably resilient in the past, recovering from mass extinctions over millions of years. Our challenge is to ensure that we do not push it so far beyond its boundaries that any meaningful near-term bounce-back becomes impossible. The next few decades will be critical. Researchers are already sounding alarm bells that each fraction of a degree in global warming, accompanied by further carbon dioxide buildup, intensifies ocean acidification. By the time we reach 2050 or so, we will have a clear sense of whether widespread interventions have decelerated the driving forces behind the chemistry shifting in the seas. Emerging technologies like direct air capture or advanced marine permaculture might help if integrated responsibly into broader environmental strategies. Yet none of these measures can work in isolation. Our best bet is a multifaceted approach that reduces emissions, preserves habitats, and fosters robust monitoring. Indeed, more thorough and constant observation of oceanic pH levels around the world is vital. Widening the network of observational stations, outfitting research vessels with advanced sensors, and ensuring that coastal nations conduct frequent chemical analyses all serve the greater goal. Track the changes in near real time, adapt policies swiftly, and share data transparently. At this point, you might be wondering, how can you personally make a difference in this seemingly massive challenge? Reducing your individual carbon footprint by cutting back on wasteful energy usage, opting for greener modes of transportation, and supporting sustainable fisheries is certainly a start. However, a problem of this magnitude ultimately depends on system-level changes. Hence, advocating for climate-forward legislation, using your voice in local and national forums, and backing political leaders who prioritize science-based environmental policies can create the momentum needed for decisive action. For those who live by coastal areas, volunteering in local marine conservation projects or citizen science initiatives can provide invaluable data to researchers. Bringing awareness to your community, whether through social media or in-person discussions, can help shift cultural norms around how we view and treat our oceans, driving forward the broad transformations required. And so, we come to the moral of this story. Do not let that invisible swirl of chemicals beneath the water's surface fool you into complacency. Ocean acidification is not just a problem for niche scientists or exotic wildlife. It is a blueprint of how deeply interconnected we all are with Earth's marine systems. If you feel that sense of urgency that these facts convey, share your thoughts, your knowledge, and your convictions far and wide. If you have not done so already, think about how today's small choice might lead to broader change tomorrow. In times of unprecedented ecological shifts, every gesture can accumulate into something greater. The sea, after all, has shaped human cultures for thousands of years. It has provided food, transportation, recreation, and wonder on a scale difficult to match. It is both the mother of all life and a reservoir of potential for our future. Yet, we must face the uncomfortable truth that large swaths of its waters are becoming more hostile to the very organisms that fashion the reefs, dunes, and vibrant realms we have marveled at for centuries. The question now is whether we will step up to protect it. The boundaries have been crossed. The conflict is not between environmental idealists and economic pragmatists. Rather, it is a fundamental challenge to how we choose to manage our planetary home. Pushing for urgent emissions cuts, supporting creative marine conservation methods, and contributing to scientific monitoring represent the triple pillars of a strategy that might still avert the worst scenarios. Ocean acidification is not a trendy buzzword. It is a life-altering reality, and while certain thresholds, like the one discovered to have been crossed in the year 2000 and then again by 2020, stand as stark warning signs, we are still in a position to reshape this narrative. Future generations yet unborn might look back on this moment as the time when humankind either rose to the challenge of reversing a cataclysmic trend or allowed it to run rampant until the ocean systems underwent irreversible transformations. That choice ultimately belongs to us today. If we take one message to heart, let it be that, yes, time is short, but our capacity for change can still match the scale of the crisis.